Okay, so let me start by explaining your calendar. So you have, well, first of all, I moved the test to Monday. Not a big fan of Monday tests, but I don't feel like we're really ready for a test yet. And so I moved it to Monday. I'm going to give you back some homework and stuff tomorrow. I'm also going to give you back the second quiz. I only graded one class period, and it wasn't y'all's. And when you're grading the proofs, like, it is an excruciatingly difficult thing if your proof isn't perfect, because some of y'all, I can't follow what you were even thinking. So if at the very beginning you make stuff up, there's not even anything to give you partial credit for. Does that make sense? Like, I can't, then you're just really making stuff up, and I didn't want it, so it was either like you did really well or you pretty much got a 2, that sort of thing. So I decided I'm not going to take the grade. What I'm going to do after everybody's taken it is I'm going to give it back to you, and then I'm going to make a video of me working it all and maybe working it more than one way and explaining it, and then it's on you to figure out if you knew how to do it or not. Okay? Does that make sense? I just felt like you needed to be able to do it, but it's going to be on you to make sure you understand it. Same thing kind of goes with some of the homework. When you get the homework back tomorrow, some of it is going to be graded on completion, because if I was to actually grade, because obviously at the end you get cosine equals cosine. That's what you should get. Well, what you have in the middle might be stuff you totally made up. Not on purpose necessarily, but you broke a bunch of rules or whatever. So you can come in, and you could have done this before it was due. Come and check yourself with my keys, ask me questions, but it's going to kind of be on you to double check that as well. Okay? So just FYI on that. This right here, you have between today and next Tuesday, you have a minimum of 2 hours on satpractice.org. That's 15 minutes a day, okay? I don't think that's too much to ask. You can do the whole 2 hours at once if you want, but minimum of 2 hours total. Some of you, when I was looking at the time, some of you have been practicing anyway, so that's definitely not going to be difficult for you. When you do this, though, you need to make sure that whatever account you're using is the one that you're actually in my third period class, or my class period for whatever class period you're in Khan Academy. You just going to your, quote, teachers in Khan Academy and my name popping up, if you had me 2 years ago, that may be false information, because I think I still show up as a teacher even though I got rid of those classes. So just FYI, because I just remember at the beginning of the year when I was trying to connect everybody, that was happening for some people, so I don't know if that's really the case or not. But what I did, so you can make sure, is I assigned in Khan Academy, I gave you a, quote, assignment. All I did was I assigned some SAT material, and they're articles. It's not even problems to work. And whether or not you read them or not, that's up to you. They're short. I think they're good information. I didn't just put random stuff in there. But even if you don't, if you can see it and you have an assignment, then you know that you're actually in my class. Does that make sense? That way you're not confused about whether or not you're in the class. And I think probably, let's say you ended up using a different Khan Academy account. I think that if I put you in there, I can still see the time you've done, okay? So like I can't see your SAT scores, things like that through there, but I can see the amount of time and the number of questions and stuff like that you've done, okay? So that way I'm not assigning specific problems. It's up to however it's tailored to you. But math part, you can do English too, but I want 2 hours on math, okay? Yes, sir. Well, I've kind of decided to do this instead because it took some people just don't even have theirs back to even look through it. I know. And then it's next week that we need it. So I thought, and as I went through those, I thought, that's PSAT, this is SAT. The SAT stuff is more challenging. It's probably better for you to actually just spend time on this. That's kind of what I decided with that. So, okay, yeah, I know. So I kind of gave up on that. And if you have your book, you can have it back. Okay, so with all that said, let's move on to what we're doing today. You do need your reference chart today. This is going on, dang it, 121, thank you. Already forgot as I clicked over. Because we are still solving equations like we were yesterday, but yesterday all we had to have was pure algebra knowledge and then some trig at the end to get the answers. Well, here you're going to have to do some substitution before you can do that algebra. So on number 1, I've got 2 trig functions. I have cosine and I have sine squared. Sometimes if I have 2 different trig functions, it's fine and I can factor them away from each other. This one isn't going to work that way. So I need something to substitute. What do you think I could substitute in here? Good. I can substitute for that, right? So I get cosine x minus 1 equals 1 minus cosine squared x. So I have a quadratic. I want to set it equal to 0. I would like my squared term to be positive, so I'm going to move everything to the left. It's going to give me cosine squared x plus cosine x minus 2 equals 0. So what do I need to do now? Factor. So I'm going to factor this into two binomials. Be cosine x and cosine x. And what are my two numbers? Positive 2 and a negative 1. Then I can use my zero product rule. And so we know that cosine x plus 2 equals 0. I'm just going to skip to cosine x equals negative 2 and cosine x equals 1. I didn't do that yesterday because I don't want to completely freak anybody out, but you know how to solve these things. All right, so I'm going from negative infinity to infinity. When does cosine equal negative 2? Never. It doesn't. That doesn't even make any sense, right? When does cosine equal 1? 0 and 2 pi and 4 pi and 6 pi and negative 2 pi, right? Because we're going from negative infinity to infinity. So all I have to put here is I don't even have to put the 0. It's just plus or minus 2 pi n. Okay, we're good? All right, good deal. No, that's fine on these. We would do it on every single one. So it's just kind of a given at the beginning. All right, number 2, I have cotangent squared theta minus 3 cosecant theta plus 3 equals 0. So I have two different trig functions here that are not going to factor away from each other. So what could I substitute? Okay, so cosecant squared theta minus 1 for cotangent squared. I'll agree with that. So cosecant squared theta minus 1, then I have minus 3 cosecant theta plus 3 equals 0. So I'll just clean that up and get cosecant squared theta minus 3 cosecant theta plus 2 equals 0. It's a quadratic, so I need to factor it. So I get cosecant theta and cosecant theta. The signs are both going to have to be negative, and what are my numbers? 1 and 2. Okay. So then I get cosecant theta equals 1 and cosecant theta equals 2. Bless you. But I would like the reciprocals, so sine theta equals 1 and sine theta equals 1/2. I'm going from 0 to 2 pi. So when does sine equal 1? Pi halves. And when does sine equal 1/2? Okay, pi 6 and 5 pi 6. So when I put it all together, that'll give me pi 6, pi halves, 5 pi 6. Okay. What questions do we have? Yes, sir. This is on their chart because cotangent squared plus 1 equals cosecant squared. The Pythagorean identities up there. Huh? Did I do that wrong? No. Oh, like, oh crap. Yeah, so on here it says cotangent squared theta plus 1 equals cosecant squared theta. You see that? But I needed to replace cotangent squared. So cotangent squared is cosecant squared minus 1. Does that make sense? Okay. So it was this was replaced by that right there. Okay, we good? All right, anything else? All right. Let's look at number 3. I have 3 tangent alpha. And by the way, this is an alpha. People keep saying, well, it looks like a lowercase a. It might, but it's drawn like this. It's a fat Jesus fish, or like a cross between a Jesus fish and a blowfish, and think of it that way. I don't know. But it actually is an alpha. My alphas look way worse than that, but it's, whatever. Okay, so I have 3 tangent alpha minus 2 square root of 3 sine alpha. I don't have anything squared, so I don't have anything to substitute as far as that's concerned. Really, the only thing that I can do is I know that tangent is what over what? sine over cosine. So let me try changing that. So this is going to give me 3 sine alpha over cosine alpha. Turn that off, please. Minus 2 square root of 3 sine alpha equals 0. Okay. What could I do here? Okay, I'll let you think. I could get I heard common denominator, and I could get a common denominator, and there's nothing wrong with that, but I don't necessarily have to. How many terms do I do what? Factor out the sign. Do I have a GCF? Yeah, let me go that way. Because if I was trying to prove something, then yeah, common denominators is most likely what I would need to get. But I'm trying to solve this, so I have 2 common factors, so I'm going to factor out a GCF. I'm going to factor out the sine alpha. That leaves me with 3. Now, this leaves me with 1 over cosine, and 1 over cosine is secant. And then that's minus 2 square root of 3 equals 0. Everybody with me? Okay, yes? Oh, I thought I heard no. Okay. So now I have it's factored. I have 2 different trig functions, but they're factored away from each other, so I'm good. It's factored. I can use my 0 product rule now. So I get sine alpha equals 0. And then this gives me 3 secant, oh, I lost my alpha there. Alpha or equals 2 square root of 3. So secant, oh my gosh, I did it again. Alpha equals 2 square root of 3 over 3. But I don't really want secant, I want cosine. So cosine alpha would be what? Square root of 3 over 2. All right, so I'm going from pi to 2 pi. When is sine 0? At pi and 2 pi. And then when is cosine square root of 3 over 2? (11 pi 6). It is a pi 6 angle, but I can only do the 4th quadrant. So that means then that alpha is equal to pi, 11 pi 6, and 2 pi. Okay? What questions do we have? Say that again. What? Well, you can. I mean, if you want to think in terms of secant and cosecant, you can. But I think most people's brains, myself included, if I can make everything into sine and cosine and tangent easily, as far as the values are concerned, they come to me a lot quicker. Like I can come up with the secant values, but I'm going to think my way through cosine before I get there anyway, so might as well just jump to cosine. Okay, we good? All right. But yeah, it's fine. If you want to leave it as secant and you know what that is, go for it. That's all fine and good. All right, so let's look at number 4. Bless you. Bless you. So once again, I don't have anything squared. Secant is 1 over cosine, and tangent is sine over cosine. So I could try and do it kind of like I did this one. It's not going to work, though, so I'm going to write it down. We're going to talk about it, but don't write it down, because then you'll have to erase it. And so let's say that like what you're thinking is, all right, I'm going to do it just like I did number 3. So I would make this 1 over cosine x minus sine x over cosine x. Okay, and now I'm thinking, okay, you know what? I could factor out a 1 over cosine, but this equals 1. Before you start factoring anything out, it needs to be equal to 0. Does that make sense to you? So I could set that equal to 0, but then I'd have to get a common denominator of cosine. Then I'd have sine and cosine mixed again, and I'm just kind of going in circles. Okay, and so that's actually how I started this one. I was like, oh, I can do it just like this. And then once I wrote it down, I was like, oh, no, I can't. So that happens. That's going to happen on this stuff. You're going to start one way and then realize, yeah, this probably isn't the best, and then you've got to start over. Well, to factor it to solve it like we are. Does that make sense? It's not illegal to factor it out. It's just not going to really get me anywhere. Yeah, then I'd have to move it, and then I wouldn't be able to factor it to solve it, that sort of thing. Okay, so that's not going to work for us. So then we have to think about something else, right? Well, really, there's no squared stuff, your only thought is, well, your reciprocals and quotients, unless it's like a double angle or a half angle, and it's not. But secant and tangent are related in the Pythagorean identities, right? Our problem is just this isn't squared. So we can get it that way. So I'm going to move tangent over. So this leaves me with secant x equals tangent x plus 1. Okay, so all I did was move it over. If I square both sides, because since we're solving and we're not proving, whatever I do to one side, I have to do to the other, that whole thing. I'm going to square both sides. Now, when you do this as a method of solving, there's a little extra step at the end. So I'm going to put a little star there, so hopefully I don't forget to do it. So then I'm going to square the left-hand side. This gives me secant squared x equals, is this tangent squared x plus 1? No. It is tangent squared x plus 2 tangent x plus 1. All right, so now I've got some squared stuff, but I still have two trig functions. Can I substitute? What can I substitute for secant? Tangent squared plus 1, right? So tangent squared x plus 1 equals tangent squared x plus 2x plus, oh, not 2x, sorry. Oh, 2 tangent x, I'm making up stuff. 2 tangent x. Yeah, I know, it would freak them out. But it's really not that bad once you know what you're doing, right? All right, so now that I just have all tangents in numbers, and that's better. So now when I start to solve, if I subtract tangent squared from both sides, what happens? They zero out, right? And then 1 minus 1, there you go, those zero out as well. So I'm left with 0 equals 2 times tangent x. So when I divide both sides by 2, I get 0 equals tangent x. And we're going from 0 to 2 pi. So when is tangent 0? Okay, so that would be 0 pi into 2 pi. Okay? Everybody good so far? Remember, we have an extra step now. Because what we did to be able to solve it was square both sides. No. Well, I mean, that sort of comes into play, but I don't need a plus or minus anywhere. We took anything that was negative and squared it, and now it has a positive answer that goes with it, that sort of thing, okay? So we've kind of increased the number of possible answers when they weren't really in the original one. Does that make sense to you? So we need to check for extraneous answers because some of these may not work. So if you square both sides, which is a legal thing to do, to solve the problem, then you have to go back and check each one of your answers. So to do that, we just take this and substitute it into the original. So that we're going to do secant 0 minus tangent 0 equals 1. And we want to see if that is a true statement, okay? So what is the secant of 0? Yeah, secant's a reciprocal. See, this is why you want to go back to sine and cosine. Secant's a reciprocal of cosine. The cosine of 0 is 1, and the reciprocal of 1 is 1. Okay, so what is the tangent of 0? 0. So 1 minus 0 equals 1. Is that a true statement? Yes. Okay, so 0 works. We like that one. Like, this is good. So then I got to do this for pi. So the secant of pi minus the tangent of pi equals 1. All right, so what's the cosine of pi? Negative 1, and the reciprocal is negative 1. Minus, what's the tangent of pi? 0. So negative 1 minus 0 equals 1. Is that a true statement? No. So pi is an extraneous answer. Right? Then I have to do 2 pi. So secant of 2 pi, it is, minus the tangent of 2 pi equals 1. Should be the same as 0, right? Because you're in the same spot. So we'll get 1 minus 0 equals 1, so that one works. So your two answers are only 0 and 2 pi. Okay. Again, you do not have to check all of your answers every time. It's only if the way you solved it was to square both sides. Okay? Pretty much. That's the only way to get it done. Yeah. Because we took whatever these values, it has to do with the values of what you have. You took these, and any solution that's in there that would be negative, when you square it, you've now made the negative ones into positive ones and kind of doubled the amount of solutions that are there, period. Does that make sense to you? So that'll throw in extraneous ones that don't really work because it's not really squared. Does that help? Okay. There's a better mathematical explanation, but it's kind of, that's kind of the easiest way to explain it right now. All right. Number 5. So I have a double angle. I definitely want to get rid of that double angle. Okay, so sine of 2 theta is 2 sine theta cosine theta. So this is going to become 2 sine u cosine u. And then I have this 4 cosine u and 3 cosine u. I'm going to subtract the 3 over, so that just leaves me with cosine u, and that equals 0. Because it's the sine of a double angle. It's on your chart. Look for the double angles. Sine 2 theta. All right, so how many terms do I have here? 2. Do they have anything in common? Cosine u. All right, so I'm going to factor out the cosine. That leaves me with 2 sine u plus 1 equals 0. So I have 2 different trig functions, but I factored them away from each other, so it's fine. And I can solve it. So cosine u equals 0, and sine u equals negative 1/2. Right? I'm going from 0 to 2 pi. So when is cosine 0? Pi halves and 3 pi halves. And when is sine negative 1/2? 7 pi 6, 11 pi 6. Y'all just letting Rigo shout out anything back there. Nobody else is chiming in. Okay. I appreciate your participation, Rigo. So we got pi halves, 7 pi 6, 3 pi halves, 11 pi 6. They can't hear what you say, though. Huh? I brought you in? Well, yeah. Well, because he's participating. That's good. No. All right. I might have. Oh. Okay. Focus back up here. All right. So here's the kind of the confessions of a bad teacher. I had to work number 6 a few times because I kept working it as cosine 2 theta, and then I couldn't get what I was trying to get. Then I realized I was stupid and I couldn't read. So always make sure you're using the right thing and don't make up math. All right, so I have cotangent of 2 theta times 2 tangent theta plus 2 equals 0. So I have a double angle. So when you look at your double angles, you don't have a cotangent double angle, but you have a tangent double angle, and you can use the reciprocal. Okay, so and then so we're just going to substitute that in. We've got 1 plus cosine theta. Oh, 1 minus. I'm making stuff up. My goodness. At least I'm not using cosine double angle. I did. What the heck am I writing down? I don't even know what I'm doing. Okay. Oh, there it is. I see it. I looked away, and then I looked back at the wrong one. Okay, 1 minus tangent squared theta. I got it now. I'm good. I can work this. Over 2 tangent theta times 2 tangent theta plus 2 equals 0. How many terms do I have here? On the left-hand side of the equal sign, I have 2. Your terms are separated by addition and subtraction. This is all one term, and this is one term. Some of y'all are doing weird things with trying to separate your fractions, and I don't get it, okay? I could actually just extend this, boom, and now it's all one fraction, and everything up there is true, except I would need parentheses here, but still, that's all one thing. I can cancel these out, so this leaves me with 1 minus tangent squared theta plus 2 equals 0. Now I have 3 terms on the left-hand side, just by the nature of what was happening. So if I add tangent squared to both sides, I'm going to get 3 equals tangent squared theta. So tangent theta equals what? What's tangent theta going to be? plus or minus the square root of 3. Okay, this is going from pi halves to 3 pi halves. And when is tangent plus or minus the square root of 3 in that interval? 2 pi thirds and 4 pi thirds. Good. Because it's plus or minus. That's going to be the downfall of some of you. You don't want to be taken out by a plus or minus, do you? All right, what questions do we have? All right, let's look at number 7. Okay, so although it kind of looks like these are the cofunctions, they're not, because the cofunctions are strictly pi halves minus theta. I don't have a pi halves in there at all. So instead, this is the sum and difference angle identities. So if you look at the difference of angles, we start with the sine of a minus b. So I'm going to substitute that in. This is going to be the sine of pi 6 times the cosine of beta minus the cosine of pi 6 times the sine of beta. Okay, so that's from your sine of pi 6 minus beta. Then minus, when I do this one, this is more than one term. You have to have parentheses. I cannot stress that enough. Then cosine of a minus b is going to give me cosine of pi thirds, cosine of beta, plus sine of pi thirds, sine of beta, equals square root of 6 over 2. If you can actually evaluate something, evaluate it and get the trig out of it. What is the sine of pi 6? 1/2. So this is 1/2 cosine beta. What is the cosine of pi 6? Square root of 3 over 2. So we have minus square root of 3 over 2 times sine beta. Then minus, what's the cosine of pi thirds? 1/2 times the cosine beta. Then minus, what's the sine of pi thirds? Square root of 3 over 2 times the sine of beta equals the square root of 6 over 2. Okay, so that cleans it up a little bit. Now I can combine like terms. I have 1/2 cosine beta minus 1/2 cosine beta. Those zero out. Here? No, because I have this minus in these parentheses. Yeah, that's why those parentheses are so important. And then negative square root of 3 over 2 sine beta minus square root of 3 over 2 sine beta. What does that give me? Negative square root of 3 sine beta equals square root of 6 over 2. Okay? We all good so far? Yes? Jenny? Jenny's giving me dirty looks. I can tell she's confused. Where did I lose you? Because I have half a 1 minus half a 1 gives me a whole 1. All right, so now I need to divide both sides by negative square root of 3, which is the same as multiplying by 1 over negative square root of 3. So this gives me sine beta, hang on, if I can write correctly, sine beta equals negative square root of 6 over 2 square root of 3. Do I need to actually rationalize? Or can I? No. These are both under the square root. I can reduce. 3 goes into 3 once, goes into 6 twice. So sine beta is negative square root of 2 over 2. My interval is 0 to 2 pi. So when is sine negative square root of 2 over 2? Oh, what does it sound like? 5 pi fourths and 7 pi fourths. Bless you. All right, we good? Yes? All right. Let's look at number 8. I got cosine of x plus 2 equals sine of x over 2. So I know I'm going to need to substitute something for that half angle. So let's go ahead and leave cosine alone and take care of that and see what happens. So cosine x plus 2 equals, so the sine of the half angle is plus or minus the square root of 1 minus cosine theta, or cosine x, sorry, over 2. All right. So what am I going to need to do to be able to solve this? Square both sides. And I'm going to need to, at the end, then check my answers, right? So I'm going to square both sides. So on the left, I get cosine squared x plus 4 cosine x plus 4 equals 1 minus cosine x over 2. All right, so what might be the next thing you'd like to do? Multiply by 2. When you do that, make sure you do it legally. Not everybody always does it legally. When I multiply 2 over here, I have to multiply by every single term. So this becomes 2 cosine squared x plus 8 cosine x plus 8 equals 1 minus cosine x. So now fractions are all gone. That's good. I got a quadratic, so I'll move it all over to the left. So I have 2 cosine squared x plus 9 cosine x plus 7 equals 0. So then I have a quadratic, and I need to factor. So this is going to have to be 2 cosine x and 2 cosine, oh no, I'm sorry, not twice, duh, hang on. Okay, and then cosine x. My numbers are going to have to be 1 and 7, so I just got to figure out where they need to be. So I think this needs to be plus 1 and plus 7. Right, that'll give me the 9 in the middle. All right, so then, isn't what 2? That's the correct factoring. We ain't got time to talk about factoring. You got to figure it out. So cosine x equals negative 7 halves, and cosine x equals negative 1. You may not factor the way I factored. You may need to do grouping or something, and that's fine, but that's the right answer. So now that I have this is going from 0 to 2 pi. When is cosine negative 7 halves? Never. Doesn't even make any sense, right? And when is cosine negative 1? Pi. Okay, because we squared both sides at the beginning, we need to check our answers. We only have one answer to check. Well, because I can just mark it out, and then it's the empty set if it doesn't work. That's okay. It's a good question. All right, so then I'm going to substitute this in, and I'm going to get cosine of pi plus 2 equals sine of pi over 2. All right, so what's cosine of pi? Negative 1 plus 2 equals, what's sine of pi halves? 1. So does negative 1 plus 2 equal 1? Yes, it does, and so we're good. Well, I boxed it in on the other one, too, and then I had to mark 1 out. It's okay. Plus, it's just habit. Mine's going to get boxed no matter what. All right, number 9. I got 1/2 tangent of a over 2 minus cosine squared a over 2 times cosecant a equals 1. All right, so those half angles, clearly I need to do something with those. So let's substitute for our half angles here. So get 1/2. Now, your tangent of your half angle, you have 3 choices. Tangent is not getting squared, so I am not choosing the first one. If it was getting squared, I probably would choose the first one, because then I wouldn't have to square the other stuff. Does that make sense? Just kind of a way to think about it. Also, I would rather have my 2 terms in the numerator than in the denominator, so I'm going to choose the second one. And that's going to give me 1 minus cosine theta over a. Oh my gosh, thank you. Cosine, I know. You deserve such a better teacher. All right, the over sine a. Okay. Minus, and then cosine squared. So whatever that is, it's going to end up being squared. So for cosine of the half angle, I don't have more than one choice. So I'm just going to put that one in. This is going to be 1 plus cosine a over 2. And then cosecant is 1 over sine. So I'm going to go ahead and change that to 1 over sine a. And then that equals 1. Okay. So I just substituted in stuff for the half angle, and I changed my cosecant to 1 over sine, because there wasn't any other cosecant things in there. Because it's cosine squared. Right? Okay. All right, so when I clean this up, this first fraction becomes 1 minus cosine A over 2 sine A. Then minus, once I square this one, it just becomes 1 plus cosine A over, and that'll be 2 sine A, and that equals 1. Okay, we good? So we have two fractions, and we have a common denominator, so that's nice. So let's combine those. That common denominator will be 2 sine A. Then this 1 minus 1 zeroes out. Then I have negative cosine minus cosine is going to be minus 2 cosine A equals 1. So the 2's cancel out. What's cosine over sine? Cotangent. So negative cotangent A equals 1, which means cotangent A equals negative 1, which means when I do the reciprocal, tangent A equals negative 1. I'm going from pi to 2 pi. When does tangent equal negative 1? 7 pi fourths. And although we did square stuff, that was part of the original problem. It's not like we decided to square something. We didn't have a choice. So that's my answer. Okay? We good? What questions do you have? Algebra, algebra, algebra. You have to be able to factor. You have to be able to handle fractions.
So remember we introduced the square root?